Today we will talk about the complex numbers. This is section 6-8 in your textbook. The essential question we will attempt to answer is, how do you add, subtract, multiply, and divide complex numbers? First, we will want to determine what is the definition of a complex number. A complex number is a number of the form a plus bi, where a and b are real numbers. So now let's look what we get if we add complex numbers. So the rule for the sum of complex numbers. So let's say we're adding two complex numbers. The first is a plus bi and the second is c plus di. If we add them together, we simply add the real parts and then add the imaginary parts. And the result will look like this. The quantity a plus c plus the quantity b plus di. So again, as I say, you add the real parts, the a plus c, and you add the imaginary parts, b plus d. But the imaginary parts need to be multiplied by I. So this is how you handle the sum of complex numbers. So the product of complex numbers, say we're multiplying a plus bi times c plus di, is handled the same way we did when we were foiling. Okay, so we simply FOIL these, first, outside, inside, last. And the final result, after we take in care of the fact that we get I squared when we multiply bi times di, is equal to the following. So our final answer would be quantity AC minus BD for the real part, plus AD plus BC for the imaginary part, times I. And as I said, this is what you get when you simply FOIL the original two complex numbers together. So let's look at some examples here. So let's say we have 3 minus 2i plus 2 plus 5i, okay? And we want to add these two together. And if we add them together, we take and we look at the real parts. We get 3 and 2, so we're just going to add those two. And we look at the imaginary parts, and we get minus 2 plus 5, and we algebraically add those, and we should get our final answer. And as you can see, our final answer is 5 plus 3i. Now, obviously, if we were subtracting, we would do exactly the same thing. We would simply subtract the real parts and subtract the imaginary parts. Let's look at an example. So our second example is going to be 3 plus 6i minus 4 minus 2i. Again, we simply algebraically add, or in this case, subtract the real parts and subtract the imaginary parts, and giving us our final result. And as you can see, we come up with a final answer of minus 1 plus 8i. So this example, we got 3 plus 4i times 5 plus 2i. Again, if we FOIL this, the first two terms, 3 times 5 is 15. The outside term is 3 times 2i, which is 6i. Inside term is 4i times 5, which is 20i. And then the last term is 4i times 2i. Well, 4 times 2 is 8. I times I is I squared. Now notice, we have a term with an I squared in it. I squared is equal to minus 1. So this term on the end here becomes minus 8. So we have 15 minus 8, which would be 7. And then we combine the two I terms, and we come up with our final answer. So, as I said, the final answer then becomes 7 plus 26i. There's one more case that we haven't talked about. So let's look at one last example here. This last example is simply going to be when we have a division problem, because we've talked about addition, subtraction, and multiplication, but let's talk about division now. So let's say that we've got, the problem would be 4 minus 3i. I wanted that red. Okay. minus 3i over 2 minus 4i. Now remember, it's non-standard to have I in the denominator, so I must multiply it by something to clear it. Well, if you remember radicals, we are going to multiply by the complex conjugate of the denominator. It's the same as the current denominator. The only difference is this middle sign is going to be changed. So in this case, it was negative, so we're going to make it positive. So we're multiplying by 2 plus 4i. But remember, whatever I do in the denominator, I have to do in the numerator. So that's 2 plus 4i. So if I FOIL these out, what am I going to get? Well, the numerator is going to end up being 20 plus 10i. Okay, first, outside, inside, last. So the final result of that is going to be 20 plus 10i. Now the denominator, when you're multiplying, is going to simply be the first term squared minus the second term squared. Well, the first term squared is simply 4. The second term squared is 16i squared. Well, remember, I squared is minus 1, so multiply that by minus 16, and we're going to get plus 1. So the denominator is going to be 4 plus 16, and so therefore our final answer is going to be 20. And let's see if we can... Alright, let's cross that out because it won't erase. Okay, and so over here we're going to write the final answer, which is going to be 20 plus 10i divided by 20. Which obviously we could simplify, and we could call this 1 plus 1/2 I. Because we always like to have our answers in the form A plus BI. Now I would like you to go to page 295 and do oral exercises number 1 and number 7 and post your answer in the drop box. Thank you.